In our previous segment, we learned that the values of the trig functions are dependent on the definition of their ratio. So, for example, since the sine of an angle is defined as y over r, and r, the hypotenuse, is always positive, because y is positive in the first and second quadrants, we learned that the trig function sine theta and its reciprocal cosecant are positive in 1 and 2. Therefore, they're negative in the third and fourth quadrants. So what I'd like to do now is I'd like to talk about a few problems where I don't necessarily want you to just type in your calculator. While you can, like if you typed on your calculator right now the tangent of 320 degrees, you would find that that's equal to, and go ahead and do it please, that that's equal to a negative 0.839. Okay, so good enough. That's what its value is. So we see that it's negative. What I'd like to do is I'd like you to be able to discern what the sign is of a trig function based on the size of the angle. So I'm highlighting the 320 degrees. So let's talk about where 320 degrees is, and let's use this picture to do that. On the x-axis, starting at 0 degrees, when I go counterclockwise, at the y-axis, I'm at a 90-degree angle. Continuing counterclockwise to the left of the origin on the x-axis, I have 180 degrees, and continuing on another 90 degrees, I'm at 270, and then finally when I go back to 0, I can call that 360 degrees. These are called coterminal angles or equivalent angles. So the particular problem that I'm working on right now is an angle of 320 degrees. So that's about right here. In terms of noting it, here's 90, 180, 270, and there's about 320 degrees. So I look over here in the fourth quadrant, and I see that the only trig functions that are positive in the fourth quadrant are cosine and secant. Those are the only ones that are positive. All the other four trig functions are negative. So I could go ahead here and say that that's negative because of its location. Let's do this again. So I'm going to, I didn't mean to undo that, but I'm going to go back to this picture right down here, and I'm going to go ahead and talk about the 192 degree angle right there. And so where is that? Well, that's about right here. There's 192 degrees. So the 192 degree angle is in the third quadrant. The only trig functions that are positive in the third quadrant are tangent and cotangent. I'm circling those right now. Those are the only ones positive. So secant must be negative. And so that's all I want to know is what the sign is. I want to remind you that to find the secant of 192 degrees, what you would type on your calculator, because it's the reciprocal of cosine, you would type 1 over the cosine of 192. That's how you would type it. Let's go back again. I'm going to try to erase this. I think I actually can. That'll be easier. Let's go back and talk about a 110 degree angle and where that is. So here's 90. Here's 180. So 110 degree angle is about right there. So we're talking about that. So I'm in the second quadrant, and I go up here. And I notice that the only trig functions that are positive in the second quadrant are sine and cosecant. So cosine must be negative, and if you typed the cosine of 110 degrees on your calculator, you would get a negative value of 0.342. I really should put the 0, but I'm just going to write it like that for now. Again, where is the next problem? Where is 132 degrees? So 0 to 90, 180, 132, about right there. So I'm speaking about that angle, and it's in the second quadrant. Sine and cosecant, they are positive in the second quadrant. I'm asking you about the sign of something. So I'm just going to circle to recognize that I know that that's a positive response. And if you typed the sine of 132 degrees in your calculator, you would have 0.743. Yes, it is positive. So again, I'm just looking for the sign. A negative 200 degrees. So where is that? So a negative angle is something that you look at in a clockwise direction. So a negative 200, this would be a negative 90. Here's a negative 180. And stop right about here would be an angle representing a negative 200. So it's in the second quadrant. In the second quadrant, cosecant is positive because it's the reciprocal function of sine. So I would just say that my answer would be positive. Let's do another one. So let's go this negative 130 degrees. So I start at 0 clockwise to 90. I got to go another 40 degrees into this quadrant in order to have a negative 130 degree angle. I'm in the third quadrant, therefore. So is cotangent in the third quadrant, is it positive or negative? Again, these are the trig functions that are positive in these locations. So cotangent is positive. So I need you to become comfortable with the fact that all the trig functions are positive in two places and they are negative in two places, and then be ready to state their locations that would be true. Now just to move on, just to think about some continuation of our work in Chapter 4, writing the values of the trigonometric functions. Find the trig functions of an angle whose terminal side, in this case, passes through a negative 9, 12. So I want to go to the left 9. I want to go down 12. I'm repeating some of what we did in the first video of this section. So I'm talking about this angle. I am still yet to talk about the size of this angle. All I know is that it's greater than 180 and less than 270, because this would be 270 right here. So that's all I know, the size of this angle. But I'm going to go ahead and draw a reference right triangle, is what I've been doing all the time, just so I can see a right triangle that has a side of a negative 9 for x, a side of a negative 12 for y. And again, this would be a 3, 4, 5 right triangle. So by the Pythagorean theorem, this is a multiple of 3, multiple of 3, a multiple of 3, 3, 4, 5. The hypotenuse is 15. This says find the values of the trig functions for theta. So I want you to list all 6 for me. I want you to tell me that the sine of theta is defined as y over r. And y in this problem is a negative 12. R is the hypotenuse of 15. And please go ahead and reduce it. So I think 3 goes into each of these, 4 times up here and 5 times down here. The cosine of theta is defined as x over r. So my x value in this problem is a negative 9, and my hypotenuse is 15. Again, please reduce it. Negative 3 over 5. Yes, you can call these decimal numbers. You can call it a negative 0.8. You can call it a negative 0.6. Please know that fractions, which are what represent the trig functions, can be written as decimals. And the tangent of theta is defined as y divided by x. In this case, my y value is a negative 12. My x value is a negative 9. A negative divided by a negative is a positive, and I can reduce that to 4 over 3. Don't forget about these reciprocal functions. And all I do is I come on over here and I take this ratio right here and I flip it. So I put the 5 upstairs, the negative 4 downstairs. The reciprocal function for cosine is secant. So I'll take the reduced form. I'll take the negative 3 over 5 and write it as 5 over a negative 3. And for cotangent, I'll go ahead and write it as the reciprocal of 4 over 3, which is 3 over 4. Let's do a couple more before we close this segment. One thing I want you to know about this next problem, I'm going to go ahead and put the picture right here. X is a negative 1 and y is a positive 1. So this is a second quadrant angle. So I'm going to go to the left 1 and up 1. So if you would try to envision, I've gone left 1 and up 1. And I'm speaking about the angle whose terminal side goes through that ordered pair. What I want you to know, and often in a more theoretical program, we will not use the Pythagorean theorem per se, as in the square root of 1 squared plus the square root of 1 squared. Let me write that down for you. I'm going to drop this reference leg, and the Pythagorean theorems would say take a negative 1 and square it. That's 1. Take a positive 1 and square it. That's 1. 1 plus 1 is 2. and the square root of 2 is 1.414. We would typically leave that square root of 2 as is. That makes for an exact answer instead of an approximate. So we would say that this hypotenuse is the square root of 2. Again, this leg is a negative 1. This leg is a positive 1. And we go write the values for the sine, cosine, and tangent of the trig functions. Now I'm not going to take the time because of space on these videos. Sine is equal to y over r. Cosine is equal to x over r. And tangent is equal to y divided by x. That one we can just go ahead and call this. Let's go ahead and do these other three. So cosecant is equal to square root of 2 over 1. Secant, flip the cosine, that would be square root of 2 over a negative 1. We could reduce that and call that negative square root of 2. We could bring that negative sign up in front. And cotangent is equal to a negative 1 over a positive 1, which is still a negative 1. So, I think I'm done. But in reality, us math teachers, oh my word, we don't like radicals in the denominator in our basements. We don't like radicals downstairs. So what we do is we rationalize the denominator. So if we multiply this fraction right here by the square root of 2, downstairs, let's just talk about downstairs, the square root of 2 times the square root of 2 is the square root of 4, which is 2. But I can't just go multiplying the denominator by the square root of 2 unless I multiply the numerator by the square root of 2. This is like multiplying the original fraction by the number 1. So again, right here, this is like the number 1 is what it is. So upstairs, 1 times the square root of 2 is the square root of 2. And my final answer for this, with no radical in my basement, is called the square root of 2 over 2. Likewise, I'd have to do the same thing with this fraction for cosine. I'd have to multiply top and bottom by the square root of 2. And upstairs, I'd have a negative square root of 2 over that denominator of 2. So these are all now properly written because I have no radicals in my basement. Finally, you should stop the video right now and perform or do the work for the last problem. And then come back and watch my answer. So I'm going to go to the right 8/10 and go up 3.2. And I'm going to quickly go ahead and draw my reference right triangle. So I have a 0.8 here, a 3.2 here, and in this problem I'll have a 3.3 for the hypotenuse. And so finally, when you write the values of the six trig functions, sine is defined as y over r, so my y value in this problem is 3.2. My r value is 3.3. For me, you're welcome to just go ahead and divide out those two numbers and get 0.97. You could also write those two numbers. It's just typically we don't leave in a fraction decimal value, so you can multiply top and bottom and call it 32 over 33. It doesn't matter, for me anyway, because we're in an applied course. But just wanted to tell you that you could leave it, you could write it as a decimal, or you could clean up the decimals. The cosine is equal to x over r. I believe when you divide that on your calculator, you'll get 0.242. And tangent is defined as y divided by x, and y in this case is 3.2, x is 0.8. When you divide those two out, you get 4. I'm not sure I'm going to have time to keep this video in a proper time limit, so I just want to come on over here and say that if you took tangent and you wrote its reciprocal for cotangent, you'd have 1 over 4. For cosecant, you could just take the 3.3 over the 3.2 and get a decimal number. You could write it as 33 over 32, etc. Secant is 3.3 over 0.8. If you wrote that as a decimal, you'd get 4.123. Let's pause for now.